Second type of data transfer instructions are related to stack memory. Stack is a user-defined memory and it is used to store temporary data. The stack pointer register is used to point stack memory. Stack pointer register, that is register SP, is used to point stack memory. Stack is the internal memory area, internal RAM area, and by default stack pointer is pointing to address 07H. So when we reset a microcontroller or when we turn on the microcontroller, in stack pointer register 07H is stored. So this register by default will point to memory location, that is internal RAM memory, whose location is 07H. Now we can change this default position of stack pointer register to anywhere in internal RAM memory. For that we can use instruction move a, suppose I want to move this position of stack pointer register to memory location 20H. Then first I will store this 20H value in accumulator and then I can use instruction move SP, accumulator. That means now 20H is stored in stack pointer, so stack pointer register will point to memory location 20. Two instructions are used to transfer data to stack memory or read data from stack memory. So first instruction is push instruction. Push an address of memory location. Push is write data at stack memory. So when microcontroller uses this push instruction, first it has to check where this stack pointer register is pointing. Suppose stack pointer register is pointing to 07H. So microcontroller has to check the position of stack pointer register. So suppose contents of SP by default condition will consider are 07H. So stack pointer is pointing to this memory location. So we are assuming 07H is stored in stack pointer register. Now while executing this push instruction, the microcontroller first increment the contents of stack pointer by 1. So now stack pointer will point to memory location whose address is 08H. So after incrementing contents of stack pointer, 08H is stored in stack pointer register. So stack pointer is now pointing to this memory location. So when microcontroller execute push instruction, first it increment the stack pointer by 1 and then it stores the data from this memory location at this particular position, memory position where stack pointer is pointing. For example, suppose we consider instruction push address 01H. 01H is address of register R0 and by default it is from memory bank 0. If you want to change a memory bank, then you have to change the bits, 2 bits of PSW register. But we'll assume memory bank is bank 0. So this is the address of R0 register. So what microcontroller will do? First it will check the contents of stack pointer register. It will increment this content by 1. So stack pointer is pointing to 08 location and then it will store data of register R0 at this memory location. Suppose in register R0 25H is stored, then microcontroller will store here 25H. Now stack pointer is pointing to new position, that is 08H, and suppose I write instruction push 02H now. So what microcontroller will do? it will increment stack pointer by 1. So stack pointer will point to memory location 09H, and it will push the contents of 02H memory location. 02H is address of register R1. So it will push contents of 02H memory location, that is contents of R1 register at this memory location 09H. So if you write next instruction push 80H, so port P0 contents will be stored at next memory location. So while executing push instruction, microcontroller increments stack pointer by 1 and stored the contents of address specified in push instruction at that particular memory location where stack pointer is pointing. This is how push instruction is executed. Second instruction related to stack memory is pop instruction. Pop and then operand is address of memory location. Again address of internal RAM memory location only. So this instruction is used to read a data from stack. So for example, I can write instruction pop and suppose address of memory location is 00H. This is the address of register R0 of bank 0. So what microcontroller will do, stack is the memory area of internal RAM. So first it will check contents of stack pointer. Suppose contents of stack pointers are 07H and address of this memory is 07H. So stack pointer is pointing to this memory location. So during execution of pop instruction, microcontroller first read a data from memory location where stack pointer is pointing. So suppose here 24H is stored, or whatever data is stored previously, we are reading the data from stack. So it will check this stack pointer, it is pointing to this memory location. It will first read this data, store it in address location. So in R024H will be stored, and after performing this operation, stack pointer will be decremented by 1 and it will point to this memory, that is 06H. Now next time, suppose I write next instruction pop 01H. 01H is address of register R1 of bank 0. So what microcontroller will do? Now stack pointer is pointing to this memory location. First it will read data from this memory location. Suppose 12 is stored here. That will be stored at address location, and then stack pointer will be decremented by 1 and it will point to this memory location 05. So while executing push instruction, first microcontroller increments stack pointer and then write data. While executing pop instruction, microcontroller first read data and then decrement stack pointer by 1. Now we'll discuss how this push and pop instructions are generally used. So first, whatever order you are following for push instruction, the reverse order is generally followed for pop instruction. For example, suppose I want to push contents of port location 80H on stack. So I write instruction push 80H. Then I want to store contents of port 0 register, that is 90H register on stack. So what microcontroller will do, and will assume that stack pointer SP is pointing to this memory location whose address is 12H 12H. So at this memory location stack pointer is pointing. So address of this memory location is 12H. So what microcontroller will do while executing first instruction, it will first increment stack pointer by 1 and then store a data of 80H, this port, on this stack memory. Suppose N1 data is stored, some data is at the port, so that will be stored here. So that is at memory location 13H. Next time we are writing instruction push 90H. So again it will first increment this stack pointer, and then whatever data is stored, that is N2H, will in 90H address, at 90H address will be stored at this memory location. So at 14H, data of this 90H address will be stored. These steps will be carried out during execution of push instruction. Now after this, we have stored this data temporarily on the stack. Now we'll do some other operations, and after that we want to retrieve this data and store back into that particular register. That means N1 data should be stored back in at address 80H, and N2 data should be stored back in the register whose address is 90H. So for that, first we have to write instruction pop 90H. So while writing pop instruction, the order should be reversed. So what it will do, after execution of this two instruction, the stack pointer is now pointing to this memory location. So currently stack pointer is pointing to this memory location. Now microcontroller has to execute this pop instruction. So first, now here stack pointer is pointing to this memory location at this instant. So what microcontroller will do, first it will read a data from this memory location and store it at address 90H. So after execution of this instruction at 90H address, data stored will be N2. After reading this data from memory location, now stack pointer will be decremented by 1. So now stack pointer is pointing to this memory location, and I'll write fourth instruction as pop 80H. So stack pointer is at this memory location. It will read a data from this memory location and store it in at address 80H. So after execution of this instruction at 80H, the contents of memory where stack pointer is pointing will be stored, and after this stack pointer will be decremented by 1 and it will point to this memory location. So whatever data we want to preserve for this two address location will be stored on stack, and pop instructions will be used in reverse order.